Hello everyone, let's go ahead and take a look at series and sigma notation. Now before we started off with sequences, and now we're going to take a look at series. And series is the sum of the terms of a sequence. So let's start off by first looking at an arithmetic sequence. 36, 31, 26, 21, dot, dot, dot. And of course, the sequence generator is going to be 41 minus 5n, and that's what u sub n is going to be. Now, if I go ahead and talk about the series, I'm going to use the capital letter S to represent that, and the subscript is going to tell me exactly how many terms of the sequence I'm adding up. So for example, if I go S sub 1, well, that's just going to be equal to u sub 1. I'm not really adding anything there, I'm just taking the first term as the sum of S sub, or the series S sub 1. S sub 2 on the other hand is going to be the sum of the first two terms of the sequence. S sub 3 is going to be equal to the sum of the first three terms. And if I go S sub n, then I'm taking the sum of the first n terms of the sequence. Now, of course, as you can see, this is going to get quite long if we go ahead and write all of the terms out. So what we're going to use is what is called sigma notation, which is going to be a shorthand notation for a sum. And so if I go ahead and take a look at S sub n, which look like this, I can very simply use sigma notation, which is this symbol right here, and this notation altogether, to say that the summation from I is equal to 1 to I is equal to n of u sub I is going to represent this right there. So notice that in the position I is equal to 1 right here, that is going to be called the lower bound. Of course, it's lower than the sigma notation. And that's going to be the starting value or the initial value of whatever u sub I is. So in this case over here, it's I is equal to 1. Now the I is equal to n, which is right here, is going to be the upper bound, or the any value of your summation. Okay, so what I have here is exactly what I have here. Those two are equivalent to each other because they represent the same series of the first n terms of the sequence. Now let's go ahead and take a look at exactly how that applies to these particular series here, and let's see if we can go ahead and apply our notation to here. Now if I wanted to do that, I could go ahead and very simply go ahead and write this from I is equal to 1 to 1 of u sub I. This expression right over here is going to be the summation from I is equal to 1 to I is equal to 2 of u sub I. And this one right here is going to be equal to the summation from I is equal to 1 to I is equal to 3 of u sub I. Okay, so let's go ahead and take a look at how we can actually go ahead and use that idea to answer this question here. It says, what is the sum of the first 5 terms of u sub n is equal to 41 minus 5n? Now what that means then is that I'm taking S sub 5, which is going to be equal to the summation from k is equal to 1 to 5 of u sub k. And I know that u sub k is just going to be 41 minus 5k. Now notice this is u sub n is equal to 41 minus 5n. But we're dealing with k because that's going to be our parameter value. And so I'm going to have to express this in terms of k as well. And then what I do then is my starting values when k is equal to 1, k is equal to 2, 3, 4, and 5. So therefore this is u sub 1, u sub 2, u sub 3, u sub 4, and u sub 5. And of course that is going to be these values, of course, by using that particular sequence generator. When I go ahead and add all of those terms up, I come up with 130 for S sub 5. Now that's the brute force method. We also have 3 properties of sigma notation that we want to go ahead and use if we can, and we'll prove these as exercises, but for right now, let's just go ahead and take a look at how we can apply those to evaluate, say for example, series. So let A sub k and B sub k be sequences, and C be an element of R. So in other words, C is just going to be any number that we want it to be. So that means then that if I take the series, the summation from k is equal to 1 to n of the sum or difference of 2 sequences, I can represent that as 2 separate summations of each one of the sequences separately. Okay, this one here basically states that if I take a constant number, multiply it to a sequence generated, then what I can add all of those terms up. What I can do is I can factor out that constant value and evaluate just the summation of the sequence. Now, the last one here says that if I wanted to go ahead and add up all the terms of a particular value c, or a constant value, then what the sum of all of those constant values will turn out to be is just c times by the any value n. Now, let's go ahead and just take a look at how I can apply those properties to this same exact example. Now, if I take a look at s of 5, again, I have this exact same expression that I had here. Now, notice this is the sum or difference of two sequences. So what I'm going to do is I'm going to use property A to separate those two and introduce two sigma notation symbols. Now, what I'm going to do is I'm going to focus on this one here. In this case over here, I'm using property B to factor out the 5, and I'm using this right here, this row right here. And then what I'm going to do is I'm going to apply property C to this sigma notation here, because this is just going to be a constant. So that should come out to be 41 times by 5, which is this right here. And then, of course, minus 5 times the sum from k is equal to 1 of 5 to k. Well, that's just going to be 1 plus 2 plus 3 plus 4 plus 5. And then if I go through the math, then I'll come up with 205 minus 5 times 15, which is going to give me exactly the same s of 5 value of 130. Okay, so let's go ahead and take a look and let's wrap up and summarize. Series is going to be the sum of the terms of the sequence. So we start off with a sequence, and if we add a certain amount of terms, then we're talking about a series. In order for us to go ahead and write the shorthand notation for this series, we're going to use sigma notation, and it's going to be very important that you recognize what the upper and lower bounds are, because that's going to tell you which is the first term of the series and which is the last term of the series. Now, we also have three properties of sigma notation which we can use to also help us determine the value of a particular series. So it's going to be very important for us to remember the relationship between series, sigma notation, and the sequence upon which the series is based. So we'll take some questions the next time that we see each other in class. See you then. See you later.